Okay, let's take a look at the law of sines. To do that, we're going to first of all start with a review example where we're solving a right triangle. The law of sines, what we're going to talk about in just a minute, is the type of triangles that can be solved. But basically, this is used when you do not have a right triangle, so not a right triangle. All right, so first of all, we take a look at this triangle. I have triangle ABC with one angle that's 62. Angle C is 90 degrees. So the first thing we're going to do is find angle A. Because all the angles in a triangle add up to 180, we're going to take and subtract from 180, 90 plus 62, and we get 28 degrees. So that's the measure of angle A, which if possible, would like to avoid using, just in case there's a mistake in this calculation, then any calculation based on that would be incorrect as well. Side A is across from angle A, side C is across from angle C, and if we want, we can call this side B, but this is opposite the angle that we're given. So that's what we're going to focus on, the given angle and the given side. So let's take a look at finding side A. So side A is adjacent to the given angle. So we're going to use the tangent of the given angle is equal to the opposite side over the adjacent side. So from here, we're going to cross multiply. I get A times the tangent of 62 equals 22.6, which means A is 22.6 divided by the tangent of 62. We're going to go to our calculator. And the first thing to do is to make sure that we are in degrees. And so we are going to hit 22.6 divided by the tangent of 62. You don't need to close the parenthesis. The calculator just assumes you're done when you hit enter. And we get 12.02 rounded to 2 decimal places. Generally speaking, we're going to take sides and we're going to round to 2. And angles generally rounded to 1. So A is 12.2. Now let's go to C. But again, we're still using the angle. We're still using the opposite. C is the hypotenuse. So we want the sine of 62 to equal 22.6 over C. Sine is opposite over hypotenuse. So C times the sine of 62 equals 22.6. So C is 22.6 divided by the sine of 62. Go back to our calculator. Now what you can do if you want, it's a little tricky here with the trig functions, but if you hit second enter, it brings back what you just typed. All I need to do is change tangent to sine, and in this case here, just clicking sine did the job, and we get 25.60. So C is 25.60. We've got all the sides, we've got all the angles, we could move on to the next problem. Now, like I said, what happens when the triangle we have is not a right triangle? Well, in that case there, the triangle has the characteristic or the term of being oblique. An oblique triangle, should be no D there, an oblique triangle is a triangle with no right angles. So in that case, SOHCAHTOA doesn't work. Right? In that case, we can use the law of sines to give you just a little bit of an idea where the law of sines comes from. Let's go ahead, we'll take a triangle here. And what we're going to do is we are going to go ahead and label it. So A, B, C, side A, side B, side C. And what we're going to do is we are going to drop an altitude or a height. So that's going to be perpendicular. And we'll call this H for the height. Now, if I take a look at this triangle over here, this is a right triangle. So I can say that the sine of angle A is equal to the opposite, which is the height over the hypotenuse. Multiply both sides by B. So H is equal to B times the sine of A. Over here, I'm using angle B now. H is opposite. A is the hypotenuse. So I can say the sine of B equals H over A. Multiply both sides by A, and I get H is equal to the sine A times the sine of B. Now, since h is equal, so this h is equal to this h, then that means that b times the sine of a is equal to a times the sine of b. Divide both sides by the sine of a, the goal being to get the a's on the same side, even though one's an angle, one's a side. Divide also by the sine of b to get the b's on the same side. And I get that the ratio of b to the sine of its corresponding angle is equal to the ratio of a to the sine of its corresponding ratio. That is called the law of sines. And the law of sines is going to add one additional thing, that the ratio of the other side to the sine of its angle is also true. So the law of sines says in a triangle with sides A, B, and C, then the ratio of A to the sine of A is equal to the ratio of B to the sine of B is equal to the ratio of C to the sine of C. The law of sines can also be written in its reciprocal form, meaning because two fractions are equal, then their reciprocals are equal. So you can, and if you're looking at Delta Math or you're looking at certain videos on YouTube, you're going to see people write it this way, putting the angles on top. You can. I generally stick to just this first way here, but either way, it's total preference. Let's go ahead and do one example. I'm going to go ahead and do the examples on the next video.